So for our Explore number 2, debriefing our idea of fingerprinting the stars, let's just start with this. We've talked about it a few times now, but why are we comparing these spectra of stars to fingerprints? And remember, what these spectras are the colored lines or the colored wavelengths coming from those elements and stars that are emitting energy. So you actually have one down here towards the bottom. This is some spectra, right? So these are the colored lines showing the wavelengths of energy coming from each element or each star. So like here's hydrogen. It's got wavelengths at all these different energy levels. And helium, again, energy at these levels. And what we're noticing is while many look similar, there's no two that are exactly the same. So that's why we've been giving that comparison to fingerprints, is these spectra or these colored wavelengths are all different, right? They're all unique. There's no two that are identical. Every element has different energy levels it emits when it's heated up. And so therefore every single one is different. And because they are all different, what we can do is use those spectra, those colored lines, to figure out a star's composition. And when we're thinking about star composition, remember, that's a fancy word to say what the star is made of. So we're using those colored wavelengths to figure out, hey, what exactly is inside the star? And you did that activity in class. A lot of us used paper, but you could certainly have used your Notability. And we had these elements and we were comparing them to each of the stars to figure out, well, is it a match or not? So for example, I can just grab this one real quick. There it is. Whoops. So I'm just looking at helium, and I want to know, is it possible that helium is part of any of these stars? Well, when I compare the spectra, so I lined them up here. Ooh, this one needs to be a little bigger. So here I'm doing a comparison, and I want to know, are these lines showing up within the star? That's what I'm looking to compare. Well, I can see my helium lines. Actually, just going to give them a little highlight so we can see them just a smidge better. Try this again. No, it's not what I wanted. This is what I wanted. Okay. So now I've got those highlighted. Sorry. Okay. So what we are trying to see is, are these lines part of that star? So when I have them perfectly lined up, I'm looking to see, okay, does this green line show up in my star? And I can see its continuation. It does. Oh my goodness. There we go. So those two lines are a match, right? The element line shows up in the star. Here again, the element line shows up in the star. Here again, they're showing up. So I'm seeing these same lines from my helium element. Even though it's a little messy, I'm seeing those same lines show up within my star. So what that's telling me is that element has to be part of that star's composition. So when we think about how exactly can we use the spectra to determine composition, we're doing just a quick comparison of the elements and stars And the comparison is not enough. We have to know what we're looking for. To know that this element is, yes, part of the star composition, what we have to see is 100% of a match with those spectral lines. I need to see all of those match up to know that element is part of the star. And as you were going through that activity, you likely saw a couple elements that seemed common matches with the star spectra. We should have noticed that both hydrogen and helium were commonly matched or commonly found in stars. And that's because what we know about those two elements. They are our element, what we referred to last unit as building blocks, right? They're building block elements because, there's my short way to write, because they're so small and simple. They're created with just a few atomic particles. So they were some of the first elements to ever exist, and therefore the most common elements that still exist today in the universe. And so because of that, they're found in just about every star that exists and are the main ingredient in stars being essentially born or becoming stars. That's what we're going to start to investigate as we go through star life cycle. So big ideas here with our fingerprinting activity. We're seeing these colored wavelengths or spectras from both stars and elements when they're heated up. And because every star spectra and every element spectra is a little bit different, just like people's fingerprints, we can use them to figure out a star's composition or what it's made of. The way we do that is we compare the element spectra to the star, and we know that element is part of the star if we see 100% match of the element to the star's spectra. We see a lot of matches with the elements of hydrogen and helium because they're so common due to the fact that they're the smallest and simple elements that exist. No other element can exist without these two. These have to be first. There are building blocks, and then we can kind of advance from there.